In the previous video, I talked about advantages of decision trees and why, some reasons of why choosing them. In this video, I will do the opposite. I will talk about why not to choose decision trees, and this means that I'm going to talk about inconveniences. Well, the first inconvenience of decision trees is that the training algorithms used to create the decision tree model are really greedy. So the first is greedy training algorithms, and one reason why these algorithms are greedy is because they need to find the optimum split at each node, and we have multiple nodes in our decision trees, right? This is why they can take a lot of time to create or to train the model. And in fact, the time needed to create a decision tree model is exponentially dependent upon the number of training samples. So here M is just the number of training samples, and as this number grows, then the time required for training increases. The second problem in decision trees is overfitting, which is an inherent problem in decision trees. And to avoid that, of course, we need to regularize the decision tree. So I talked in a previous video about how to do that, some techniques to avoid overfitting decision trees. So this is something necessary to do on a decision tree, otherwise you would get a model that overfits the data. The third problem is the class bias. Therefore, one of the few pre-processing needed or data preparation needed is to balance the classes. But first of all, let's understand what is class bias. So to understand that, let's imagine a situation where I want to create a predictor that predict a given sample as either as class 1 or class 2. So, and to create the decision tree model, I used 80 samples for class 1 and 20 samples only for class 2. So in that case, the decision tree classifier would be biased to class 1. So most of the time we would get class 1 even if the sample is not actually a class 1, it's just a class 2. And to avoid this problem, we need to do a simple pre-processing on the data. So we need to balance these two classes. So we need to have the proportion of this class almost equal to the proportion of this class, and this would allow us to avoid the problem of class bias. But so here I talked about three problems, and the biggest problem of decision trees is the inaccuracy when compared, of course, with other models. The first problem, or the first inconvenience, is the inaccuracy, and this has basically two aspects. The first aspect in the regression, and the second aspect is the instability of the model. I will talk about these two concepts quickly. The first is regression, the second is instability. Now, why regression is a problem? Well, it's a problem because, for example, say this is a regression model, and you can see the different boundaries created by the decision tree model. So in that case, I have only 4 possible outcomes. In other words, I cannot predict continuous values using this model. Of course, I can increase the the resolution of this model by increasing the number of possible outcomes, but I will never be able to predict continuous values. And this is one of the inconveniences of decision trees. So this was the regression problem, and the second is the instability of the model. And there are two factors that cause this instability. The first factor is sensitivity to data rotation, and the second is sensitivity to add in a new data point or new training samples. So these two factors cause a big change in the model. I will explain how. So this is an example of a decision tree model. So let's focus just on this figure here. So here I have two classes. So this is the first class, which is in circular dots, and the other class is the triangular class. Well, the decision tree obviously separates these two classes by one nice vertical line like that, and everything is okay. But if I were to rotate this data here by, say, 45 degrees, then what would happen is, instead of rotating just this created model here, this is what happens. I have a completely different model, and this is of course due to the nature of decision trees that has to divide the dataset with either vertical or horizontal lines. Okay, so here in this case, for example, I could have separated this data just with a nice linear model, and I could have obtained better classification results. And kind of the intuition why this is the case is, so this can be explained by an example. Let's say that I have a new data point here that I want to classify. So in that case, this model here would classify it as a triangular data point. And this for me does not make a lot of sense, because this data point here is closer to this class, the circular class, than it is to that triangular class. Okay, therefore, I believe that classifying it as a circular data point would be more reasonable and plausible. Okay, and the linear model could have yielded such a plausible classification. And this is just to tell you why this change in the boundary can be a problem. Now, so I talked here about the issue of data rotation and why it's a problem. Now I will talk about how adding a new training sample can also create a model instability. So for example, say that I have two features, x1 and x2, and the samples I collected are distributed in this way. So this is the first class, and say that this is the second class with the green color, so in that case, if I train a decision tree model, obviously what I would get is just a boundary here, a horizontal boundary, and that would separate perfectly my data. So this is the first class, and this is the second class, the green class. Now, what would happen if I were to add a new data point? Say that I have a new sample that I added on my training samples or training data set, and this sample turns out to be here in this position. So this is the new sample, new training sample. So in that case, the model that would be created for on the training data set with this new sample would be completely different. So in that case, I would get a boundary like this one. So the decision tree would try to create a boundary here to separate this data point here as well, and the final boundary would be like that. Okay, so this is the boundary boundary with the new training sample, and this is the boundary with new training sample. This is the boundary without the new training sample. And of course you can notice that the boundary is completely different. In this model, the second model gives me a different classification. So in that case, this model would classify this data point here as the first class. And this, in my opinion, again does not make sense, because this data point is closer to this class, so it should be classified normally as a green class instead. Okay, but this is not the case for the new model, and I think that now it's clear that a change in the model, or this instability, causes a lot of errors, and this is the biggest problem or the biggest issue with decision trees. Therefore, normally what we do is that the decision tree is used as one classifier in something that is called ensemble learning. That is, we use a lot of classifiers, and then we try to see what is the highest number of votes, which class has the highest number of votes. So I will talk about that later when talking about random forests, where we can enhance the result of decision trees by using a lot of decision trees models.